Okay, hi everyone. Good morning. Today what we're going to go ahead and work on is factoring. And to get started factoring, let's talk about what factoring is. It's undoing multiplication. It's undoing multiplication. What does that look like? Let's give us some examples of what we've seen factoring. The word factoring. We've seen it in the context of what are the factors of 10, right? What are the factors of 10? What numbers multiply to become 10? And when we say factors, we're looking at what numbers are multiplying here. So 5 times 2, those are 10, right? And we can break up, the idea is we're undoing, oops, didn't even spell that right. Undoing multiplication. Right? I totally fired up a particle beam at it, boop, and it fell apart. Right? It just totally fell apart. 10 fell apart into 5 and 2. Easy. Right? So this is how we looked at the idea of factoring. What are the factors of 12? The factors of 12 are 2, 2, and 3, right? Which were really 4 times 3. Oops. 4 and 3. And then which is really 12, right? 12 became 4 and 3, and 4 became 2 and 2. So we looked at factoring before in elementary school and in junior high. The idea is we are just breaking up numbers that we multiplied to get up to, and we broke them down into easier numbers. Great. Now, how does that fall into the context of what we've been doing? Well, we've been multiplying monomials and polynomials. If I say 3 times x plus 2, this becomes 3x plus 6. You guys okay with that? Okay. 3 times x plus 2 equals to 3 times 6. And we switched a number for a variable. So we have an x here now, which makes things just slightly more complicated. We're like, okay, sure. X stands for a number, right? X stands for a number. And let's give ourselves, what is that number? Let's say the number is 5, okay? If x equals to 5, we can write 3 times 5 plus 2, which is 3 times 7, right? And what's 3 times 7? 21. If I look at my right side here, this equation, 3x plus 6. If 3 was 5, isn't 3 times 5 15? And 15 plus 6 also 21? Right? So both these versions could work if I just plug in a number. They should work if I plug in any number. So my question now is, what numbers make up 21? Well, the numbers are 3 times 7, right? Isn't 21 just 3 times 7? And to write this in a different way, if I write this as 3 times 5 plus 6, the 3 and the 6, right? They're still there. Now, this can be written also as 15 plus 6. Okay. So I want us to look at this value here. What numbers does 15 and 6 have in common? What I mean is, what number can I divide into both 15 and 6? What numbers do they share? Well, isn't 15 3 times 5? And isn't 6 3 times 2? So we're going to do this in a different way. We're going to factor them out, meaning we're going to say, hey, didn't we multiply a 3 to both of these? So to undo our multiplication, just like here, to undo our multiplication, we're going to say, hey, what numbers do we multiply? Well, we multiplied here by 3. We're going to undo that by pulling out a 3 from each. See, I pulled out a 3 from each. I factored it out. I said, this is 3 times what? Well, that's 3 times 7, which are the factors of 21. This is looking at a very abstract way, okay? Now, it's going to be easier to look at it right here. Look at the numbers 3 and 6. do they share anything in common that I could divide them both by? Can I divide 3 and 6 by the same number? Can I divide them both by 2? No, I can't divide 3 by 2. But I can divide 6 by 2, but I can't divide 3 by 2. Can I divide them both by 3? Yes. So if I divide them both by 3, we end up with x plus 2, right? Now I'm going to go ahead and throw a 3 in front. So in order for us to factor 3x plus 6, we can factor it to become 3 on the outside because we're going to pull it out, and we have a 3x plus 2. Let me do this in another illustrative way. We have 3x plus 6. Tell me, what do they both have in common? They both have in common a 3, right? So take a look. I'm going to put in parentheses here. I'm going to pull out, I'm going to divide out a 3, and we're just going to stick that in the front. Once we pull out the 3, what's left over? We have an x plus 2. Let's double check it. 3 times x is 3x. 3 times 2 is 6. This is the exact same expression, except I took out the 3 in common. All right, let's do another example here to kind of bring everything together. I have gone through a lot of things right now in like 3 minutes. So here, factor 2x plus 10. Okay, factor 2x plus 10. What numbers can I pull out in common of 2 and 10? What numbers can I divide both 2 and 10 by? You can probably say 2. So I'm going to write the 2 in the front. Okay, I'm going to pull out the 2 in the front. Pull out a 2. What's left over? If I divide a 2 from everyone, we are left with a x by itself. 10 divided by 2 is 5. So we are writing equivalent statements. We are factoring like what we did before, except we have a variable now, which makes it a little bit harder to look at. Now, are these still the same expression? Well, yes. 2 times x is still 2x, and 2 times 5 is still 10. So the idea here is we're taking this answer and we're undoing the multiplication. Undoing the multiplication. Okay, undoing the multiplication. That's the idea here. That's a big idea, and that can be done in a lot of different techniques, because not all problems are going to be super obvious like this. Okay, let's try another one. I'm going to say ask you guys to factor 3x squared plus 6x. Now here, there's more than just numbers in common. What do we have in common here? What can I divide them both by? And the idea is they have to both be able to be divided by it. And sometimes I think of it as, what do they share in common? And what we call this is our common factors. So they both have a 3, right? 3 times 1 and 3 times 2, right? They both have a 3. And if you can see here that x and x, and this is just x, so they both have a couple of things in common. They have a 3, and they have an x each that we can take out. So let's go ahead and factor that out. I want to take out a 3x from both of them. Now what is left over? I took out a 3x from both of these. Now if you take a look in red now, maybe I'll use blue. You'll see that we have an x and a 2 left over. Let's write that, leftovers. We have x plus 2 left over. Let's double check. 3x times x is 3x squared. 3x times 2 is 6x. Same answer? Yes, they are equivalent statements. They are equal to each other, but we're writing it in a factored form, a factored way. We're undoing our distributive property. We're undoing our multiplication. Let's do this again. factor 10x squared plus 25x now, okay? Can you see numbers that are in common for 10 and 25? How about x's? How many x's can I take from these? Okay, that they have in common. We're undoing our monomial multiplication, our monomial distribution. Okay, hopefully you guys can see that I have a 5 and 2 and a 5 and 5. So we do have something common. We have x and x. We have an x here. You don't have to write this line here once you can do this in your head. This problem is really just being done in our head. Okay, so what do we have in common? Well, I can divide them both by, they both have a 5. So let's take out a 5, and they both have an x. If I take out a 5x, what do we have left over? 10 divided by 5 is 2. X. 25 divided by 5 is 5. And we took its x. Okay, so let's think of this as two friends. Okay, two friends are different. And let's say this friend here numbers are 14x squared, and this friend here is 21x. Okay? And I want you guys to tell me, what do they have in common? And you know what? Normally, this is an elementary thing where, oh, they have the same color pants, they have the same color shirt, oh, they have the same color hat, blah, blah, blah. But in this, us looking at numbers, what numbers can I say they have in common and they can share? Well, 14 and 21 obviously aren't the same number, right? 14 and 21, they're not the same number. 7, thank you. But there is a 7 here. They do share a 7. Right? So they actually do share a 7. Okay, I'm going to take the 7. What else do they share? I see you guys are saying an x, right? And an x, perfect. They have, this person has two x's, right? It's almost like they have two juice boxes in their lunch. This person has one juice box. So they have stuff in common. And what we're going to do here is I'm going to write this in a formula way for you guys and see it so you guys don't have to look at it. So what do they have in common? You guys told me they have a 7 in common and an x in common. If I take those out, what do they have left over? Now, 14 divided by 7 is 2, right? And we have an extra x left over because I took only one x out. And 21 divided by 7 is 3, and I took its x. We can double check it since we're here. 7 times 2 is 14. X times x is x squared. 7 times 3 is 21. X. We're not changing the value of the problem. We're just rearranging their stuff around. Okay. So if you guys can get this, you guys are in a great shape where you're wrapping your heads around factoring. Let's do a couple of bigger numbers here now. Ready? Okay, here's our next example. If I ask you guys for 30x cubed plus 70x squared plus 50x now. We have three terms, and can you see values that are in common for not just two, but all three terms now? Because when you're factoring, you have to make sure you have everybody have stuff in common. So I mean 10, yeah, that's right. There's a 10 in common. 10 times 3, right? That's what's going on in our head. 10 times 7 and 10 times 5. Very good. That's right. They all have a 10 in common. What else can you say that all these three terms have in common? An x, perfect. An x, thank you. That's right. You guys see that they have an x, right? This is x, 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 and x. So at least I can take some x's from these guys. So I'm going to take the 10, because they all have a common 10, and they all have at least one x in common. Not two x's, just one. So I'm going to write that in front, because it's like we're multiplying it back in. Okay. We take out what's in common. We factor out what's in common. It's almost like we filter. You guys ever use a sifter, a filter, right? And we're kind of sifting out the junk. Well, the junk apparently is what they have in common, that 10x. So we are left with 3x squared plus 7x plus 5. Take a look what we have left over. We have 3x squared, we have 7 x's, and we have 5 no x's. And we keep our signs. We can double check it very quickly. 10 times 3 is 30. X times x squared is x cubed. Okay, that looks right. 10x times 7 is 70x. X times x is x squared. Yes, 70x squared. And 10 times 5 is 50x. 50x. Right? So we're just undoing our problems of what we first learned to do. We've learned how to multiply them together. Now we're undoing it. It's almost like simple division. Okay. So for these monomial problems, for the next assignment you guys are going to work out, we're starting with the basic level. Just can you see out what common factors that they have? Can you see what common factors that they have? Okay. So our homework today is based on this work. You guys are going to be asked, very simply, hey, what common factors do they have? And then we're going to switch over to the equation version. So let's go ahead and take a look at that. Okay, let's look at this problem on your homework. The question is, what do they have in common? Find the greatest common factor. And they say greatest, if you look at 4 and 8, they have 2 and 4 in common, don't they? 2 and 4 both go into 4 and 8. But what do they want? They want the greatest. What's the greatest number that goes into both of them? They both have a 4 in it, because 4 is bigger than 2. Okay, so I would use 4 instead of 2 because they want the greatest. So we have 4 in common, and how many j's do we have in common? Is it just 1? Since they're both squared, we actually have 2 of them. So we're going to type 4j, hit the squared button, right? Because they have at least 4 in common, as well as our j squared. Let's go ahead and write this out. To show you this, 4j cubed and 8j squared. This is a 4 times j, 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 and a 4 times 2, j, j, j. We have at least a 4 in common. All right, 4 in common. And over here we have, oh, oops, I wrote too many j's, I'm sorry. We have at least 2 j's. They look like blue jays in common, right? Those are the values that are in common. And that's all you're going to type. Okay. Submit. Well, great work. Yeah, thank you. For this problem here, what's the only thing in common between 6y cubed and 3? Do they both have y's? No. They have a 6 and 3. 6 and 3 aren't exactly in common, but they both share a 3. Thank you. They both have a 3 in common, right? I can say they both have a 3 at least. Now these idea of common factors are what happens in the real world, right? If you go on a party, and does everyone have enough money to go in, right? Does everyone have enough money to eat at the restaurant? What can we have in common? Are you guys tall enough to ride the ride? Okay, so what numbers here do you think that are in common? I have 6 and 3. What numbers does 6 and 3 share? And c squared and c. What can we say we have in common here? Well, let's go ahead and pick this up. Yep, the same answer as before. For 6 and 3, so we have, I'm gonna write over here so you guys can give ourselves some space. 6c squared and 3c. Well, 3c is just 3 and c. 6, we do have a 3 there. 3 times 2, c and c. So we do have a couple of these are common. We have a 3 in common, our greatest common factor, as well as we have a c in common. So that's what we want to do. This whole activity is just to identify what we have in common. So we have a 3c in common. 3c in common. Right, so this activity here is just to get a wrap our wrap our brains around it, that we can identify what's in common. Pretty simple activity. Let's go look at our next activity today. AA.2. And then we're going to factor out our monomial like we just practiced. So for this problem here, what numbers do we have in common between 10 and 4 and k cubed and k? So the number 10 is 5 times 2, and number 4 is 2 times 2. So can you guys tell me what is the factor that they have in common? And then how many k's do we have? K, 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 and k. So in this case, we have a 5 in common. Oh, sorry, not 5. I'm sorry. 2 in common. So we're going to take out the 2. And then we're going to take out 1k from each of them. So we're going to write this as 2k. They have those in common. Now, what do we have left over? We still have a 5, k squared, and a number. In this case, it's a minus 2, right? See how this is a minus? Careful. Signs are going to kill us. Minus 2. Okay, let's review quickly how we did that. We took out of 2k from everyone. 2k times 5 is 10. K times k squared is k cubed. 2k times 2 is going to be negative 4k, right? So we're ending up with our exact same problem from before, except we're factoring out what's in common. Now you want to make sure you guys are practicing this and not waiting to the end of spring break. Do it while it's fresh, and then you guys have a great spring break. You can relax during that time. But let's get our work done first. We said we have we could take out 2 k. We have 2 left. Oh, sorry, we took out 1k. I'm sorry. We took out 2k from everyone. Let's open up our parentheses, and we have a 5. 10 divided by 2 is 5, and we still have 2k's left because we only took out one of them. Minus 2. Okay. Let's do one more. What values can I see in common between 9 and 6? What common factors can I pull out from 9, 6, and w cubed and w squared? Hopefully you can see that we have a common 3 in both of these. So I'm going to divide 9 by 3. Okay, we're going to have 3w squared. That's what we're going to pull out because that's what we have in common, 3w squared. We have a 3 in both of these, the front and back, 9 and 6. We also have w squared in both of them. Perfect. Well, if I borrow 3 from you, if I take the 3 from you, what's left with multiplication? We still have a 3, and we still have 1w left. I see a minus sign. We keep that minus sign. 6 divided by 3 is 2, right? And I have no w's left. Let's take a look here. We took out a 3w squared from both those factors, 9w cubed and 6w squared, negative 6w squared. When I take out that common factor, we have left over 3w minus 2. Okay. All right. Terrific. And that's it.